Hi, welcome to a Canto Roboflow training movie. In this training movie, I will show you the improvements that were done on the action call external application. And so calling an external application has already been available for a long time in Roboflow, and the action to be used for that is actually execute external application, and then it expects from you a command line instruction calling the application. What is important to know is that this command, the several parts of this command, should always be separated by tab characters. There are other training movies explaining this in more detail, but command line instructions could be separated by spaces, but as you know, if your parameters itself contain spaces, then you have to use quotes, etc. It becomes much more complex. So you can keep it just very simple by separating the separate parts of your instructions by a tab character, and that tab character will tell Roboflow that these are separate parameters, and it will call the external application with those separate parameters, ensuring no problems with spaces that might be inside your parameters. But this is not something new. What is new is that in the older version, or in the version before this version, before version 11, it was so that if you were executing a command, that it would pick up the resulting text that was outputted to the console and to the system out of that application. It would try to capture that and give you that back as text. But it was sometimes very hard to determine if the process was actually successful. So that is why we built in a functionality in this version that you can prefix your instruction with the word exit colon, and exit colon means that it will actually return with an exit code. So the application that you're calling gives you an exit code, and that exit code can tell you exactly what it is. We're going to use here in this little demo a little Java application that I wrote, and the only thing that Java application uses are these parameters. Don't get confused by these parameters. They're just parameters for this particular tool. They have nothing to do with the normal calling of an external command. But what I did here is that I'm forcing this little tool to give me a certain exit code on error, or exit code if it's successful. So that way you can see if it returns the normal result. By default, an application that doesn't use that technology returns a 0 as a return code if it's successful. Like if you execute a command line interface, it would return a 0. Now, if the command line batch file is not there, it might return 1 or 9 as error codes, or something different that your operating system decides this is the error code. But by default, 0 is telling it it's okay. So let's run this, and you will see what the different results are. So I just need to start this. Show log. So what happens is that in the first example, it calls this instruction, this one, and it sends a couple of parameters. These parameters tell it that this is just going to output the result, do a system out text. It's telling him that it has to wait 5 seconds before and 5 seconds after, so that it takes a while. And so the output here is, the result is just action is output. It gives you just a simple output. But you see that you don't have an exit code. You don't see what the result is. It's just the text that is outputted, and this is actually what the plugin has outputted, period. Then the next one, we're running exactly the same, but we're telling that there's a loop. The internal application, the little jar I wrote, has a little loop in there, and it will loop a number of times, 10 times I think, and then output in each loop that it has done a loop. So you can see at this point that it's not yet giving me a result because it's still doing that loop. So in each loop it waits 2.5 seconds. So 10 times is 25 seconds with a little bit of overhead of the workflow, etc. You can see that we're still waiting for this result. And waiting for a result is, of course, a very annoying long thing to wait for. As you can see, we're actually already waiting from here to here. So from 30s, and we're almost waiting. So here you can see that the instruction received out loop 1, out loop 2, blah, 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 blah. So in total, it took, for a process that took internally 10 times 2.5 seconds with a little bit of overhead, which took, let's say, 30 seconds, that in reality, for the application to come back with a result, it took almost 2 minutes. Now, there is an existing parameter here, the exclamation mark, that tells the application not to wait for a result if the output isn't changing within a certain amount of time. That is the standard functionality of Roboflow. That means that if it's not responding quick enough, it's gonna come back. It's gonna come back afterwards. It's going to come back quicker. And so we see here that it's not it was still supposed to be waiting for the output loop and to run 10 times or 9 times apparently, 9 times here, but it came back already after 4 times. And why did it come back after 4 times? Because the exclamation mark tells the application, don't wait longer than 1 minute for a result. It's just saying I launch or 30 seconds or something. It's quicker. But the disadvantage is, of course, that you also only have a partial result. So maybe if something went wrong or is going to be going wrong after that moment, it is launched in a separate thread. So it is executing, so it's not killing the task, but it's not giving you any result. So then imagine we do the same thing with the new functionality, prefixing the instruction with exit. Remember, we did this with this parameter saying we wanted 5, and it came back with a result here after 11 seconds. If we do this here for a process that, oh, I'm running too quick already, too far. So if I do that here with this process, I can see that it comes back and it tells me that the exit code is 0. Now that's a little bit strange because I asked it to tell me that the exit code was 88 if successful and 99 if not successful. And you can see if I force an error in there, if I force an error saying I made the application explode, it just explodes, then it gives me in text the explanation back that something went wrong, but it still tells me that it's 0. Why? Because we're calling a command line file, a batch file, and this batch file didn't fail. This batch file was able to execute something else. And the fact that that something else came back with an error is not something that forces the batch file to say that it was wrong. The batch file was able to execute. So you don't get back the right result. Same if I just create an error and return actually this, then you can see there is an error, but in the system out, but that information is just because my application is giving it to you. If my application were not giving it as a piece of text, then you would not know about it. So if you now, so the same thing here, if I do this for, if I call exit and I call the native Java instruction instead of calling the batch file, now I can see that I ask it to give me exit code 88 like I did in previous instructions, and it executes and comes right back and says 88. The result is 88. So now I'm able to really pick up the exit code, exactly the exit code that I was expecting to get back. If I call the exact same thing, but now I'm sending the throw instruction like I did before here. Here I was doing it through a batch file which was calling the Java jar, but now I'm calling the Java jar directly with the same parameters. I'm saying throw me an error. Well, it throws the error and it comes back with 99. This is a captured error. So within my application I detected an error and I decided the application decided I'm going to stop the application and send back an exit code. Imagine that you crash your application. So here in the Java, I'm asking to return me a 99 in terms of a crash, in terms of an error, but I'm forcing this kind of error that is not caught by the application. It's such a severe error that it just not trapped in the application, and because it's not trapped in the application, it returns with an error. What happens then is that since this is a Java application, Java returns the default error code of an application, which is 1. It just says it fails, period. So you don't have the exact return code from the application, but you have this. So you can see that with this exit, you have a much better control. But what is even more interesting is that if you send the right parameters to the application, it also comes back much quicker. So if I am sending an application call which takes a while, it comes back much faster than before. So if something is returning, taking a very, very long time to return, it is returning exactly when the application stops. It doesn't add any seconds to it. In the past, if you were run this with previous version, it would take a lot longer. It would have an overhead of a much bigger amount than in the current version. In the current version, it comes much faster back. And so you see that, for instance, here you have an overhead of 1 second. And so internally, the application pauses 5 seconds before, 5 seconds after, and then it returns. So there's an overhead of 1 second here. In the past, if you were to test this with a Cumulus 10, then you would see that it would have an additional overhead of at least 10 to 20 seconds. And so even an application that takes 1 second to execute would in this version take 2 seconds in total, and would in your old version take maybe 20 seconds. So that's what the improvements are all about. You can get the exit code back and you can execute external applications much faster. Thank you for joining this training movie, and I'll see you in the next one.